Good morning everyone. Today we are going to discuss numerical based on Norton's theorem. Okay, so this is a dependent source based question. Tell me first which source it is. Okay, this is a dependent source and in this they have given the sign of plus minus. As you know that plus minus means it is a voltage source, right? And if arrow is given, then in that case that was the current source. So in this case plus minus is given, so it means it is a voltage source, but its value depends on current because it is a current dependent. 3I means it depends on current. So which source it is? Cdvs. Cdvs means current dependent voltage source. It is a voltage source, that's why voltage source. It depends on current, that's why current dependent voltage source. Okay, now move to Norton's theorem. In the Norton's theorem, what they have said, we have to follow certain steps for that. Step number one is to short circuit the RL. Okay, short circuit RL. How can you do short circuit? Short circuit means removing that resistance, that load resistance, and instead of resistance you have to connect a plain wire. So in this I am doing this. I am connecting a plain wire across it. Okay, and mark it as A, B. Okay, our first step is completed. What was our first step? We need to short circuit RL. Now move to step number 2. Step number 2 is we need to calculate Norton current. Okay, in some book it is written Norton current and in some book it is written short circuit current, that is denoted by ISC. So both the things are same, don't get confused with them. So in this, how much current is flowing? IN current is flowing. Now our focus is to calculate IN. And how can we calculate IN? By using mesh rule. You can say that this one is a current source. Okay, in this how many meshes are there? There are 3 meshes. For 3 meshes we can take up to 3 variable. Suppose in mesh 1 I1 is the amount of current flowing, in mesh 2 I2 is the amount of current flowing, and in mesh 3 IN is the amount of current flowing. Because from A to B IN is flowing now, that's why I have took IN. Okay, now we have to make equation. We always make first equation from the current source only. Suppose this point is G and this point is H. Your current is moving from G to H, right? How much current is moving from G to H? That is 10 ampere. And we have assumed that our current I1 is also flowing from G to H. So same branch, it means I1 is equal to 10 ampere. This is the first equation we got. Next we will make the equation 2 from the mesh 2. Okay, suppose this one is I, J, K, L. You are standing at the I position. You are moving from I to J, J to K, K to L and back to I. Okay, for that you have to mark sign convention. J to K means positive to negative, here positive to negative, and here I1 current is flowing from I to L, so it would be positive to negative. Now you are at I, you need to move to J. So which source is the second sign? You have to take second sign, whatever second sign which is coming in your path, you have to take that. So I to J, what is the second sign? That is positive. Okay, and what is the value of this voltage source? That is 3I. So I am taking it as 3I. Then J to K minus, second sign is negative. Resistance is how much? 6. Current is how much? This is the middle branch. So in the middle branch 2 currents are flowing. From here I2 is flowing, from here IN is flowing. So it would be I2 minus IN. K to L nothing is there. L to I. What is the second sign? That is negative. Okay, resistance is how much? 1, and current is how much? I2 minus I1 is equal to 0. So this is the second equation. Clear? Now we move to third equation. Third equation, you are standing at the J position. You need to move back to J. J to A to B, B to K, K to J. Okay, here nothing is there, leave that. If you are moving from K to J, positive here, negative here. What is the second sign? That is negative. resistance is 6 and current how much is flowing, that is IN minus I2 is equal to 0. So this is your equation third. Okay, now you have to see that how many variables are there in this. I1 is one variable, okay, I2 is another variable, IN is another variable, and this I, because of this dependent source we have another fourth variable, that is I. So for solving 4 variable we have to make 4 equation. Okay, then only you can solve it through calculator now. So for 4 variable you have to make 4 equation. What is the fourth equation? Fourth equation can be make from this thing. Just always remember whatever the value of dependent source is given, like in this 3I is given, okay, this I is always mentioned somewhere else. Like in this case this I is mentioned here, that I is the current flowing from I to L. So always make equation from this dependent source value like this. Okay, now we'll make this equation. Now you can see from I to L, I is flowing, so I can write an I. But what we have assumed, I2 is the current flowing, L to I, just that is just opposite to the I. So I am taking it as negative because it is opposite to the I direction, and I1 is the same direction of I. You can see that I1 and I both are flowing in the same direction, so we will consider at positive. Okay, so whatever flowing in the same direction we will consider it as positive, and whatever flowing in the opposite direction, that we will consider it as negative. I1 and I are in same direction, both are in same direction, so I am taking positive. I2 and I are in opposite direction, so I am taking negative, minus I2. So this will be our fourth equation. Now we can solve this equation, right? From the calculator you can solve it easily. Then you will get the value of IN how much you got, that is 10 ampere. Up to this our step number 2 is completed, correct? Now move to step number 3. For step number 3 we need to calculate RTH. Now see how can we calculate RTH. I am moving step number 3. We need to calculate, not RTH, Norton resistance. Norton resistance, and Norton resistance is denoted by the term Rn. For Rn you have to follow certain rules, that is voltage source must be short circuited, okay, and current source must be open circuited. You can remember it like that. Open circuit means you open the door, okay, for the current, you open the door for the current. Short circuit means closing, right? So you are closing the door for the voltage. Suppose, just imagine, current are girls and voltage are boys, so you are opening the door for the girls but you are closing the door for the boys. It's like, you can remember it like that also. So I am redrawing the diagram based on this. Here which source is present? Current source is present, so current source must be open circuited. I am opening the door for the current source, right? We don't touch dependent source, just remember this point. We don't touch dependent source. Dependent source will always remain as it is, neither short circuited neither close circuited. Okay, now again next remove RL, that we already remove RL, and after removing this RL we have to place test source. Okay, after removing this RL, marked it as always A and B terminal, marked always. After removing RL, mark this point as A and B terminal, and across A and B terminal you have to place test source. Test source can be voltage source and test source can be current source. Okay, if we'll place voltage source, then take it value as 1 volt. If we'll place current source, then take value as 1 ampere. Clear? But in this question I am marking here voltage source. It's up to you only, that whatever you like, you can take any source. If you want voltage source, then you can take voltage source. If you want current source, then you can take current source. So I am taking here voltage source, that is of 1 volt. Suppose I0 is the amount of current flowing from 1 volt. Now what was our focus? Our focus is to calculate Norton resistance, right? Now see how can we calculate Norton resistance. As according to Ohm's law, you know that formula is V is equal to I into R. So R would be equal to V divided by I. So Rn would be equal to, what is the value of volt? That is 1 volt. And how much is the amount of current flowing from 1 volt? That is I naught. So Rn is equal to 1 volt divided by I naught. If we'll get the value of I naught, then we'll get the value of Rn also, correct? Now we can apply again KVL. Our current is flowing from B to A, so I am also taking B to A, that is I naught, okay? And in this also I am taking current, I can say I, because in this branch I is the amount of current flowing. So I didn't take any another variable. From B to A I naught is flowing, that's why I took I naught, and from, you can say, G to H I is flowing, so I have to I, okay? Now apply KVL. Again, you are standing at G position, you need to move it to back to G. Whatever second sign which is coming in your path, you can take that. G to F, second sign is how much? Plus 3I, right? Then plus minus, okay, plus minus. So what is the second sign? That is plus. Resistance is how much? 6. Current is how much? I minus I naught. D to H, nothing is there. Now mark sign here also, positive, negative. Now H to G, what is the second sign? Plus. Resistance is how much? 1. And current is how much? I is equal to 0. This is, we got equation number 1. Now similarly apply KVL in mesh 2. You are at A position, A to F, F to D, D to B, B to A. You can move like anywhere to anywhere, it's up to you. A to F, nothing is there, leave that. F to D, negative. Resistance is 6. Current is flowing I naught minus I, okay. D to B, nothing is there. Then negative, positive, second sign is plus. 1 is equal to 0, okay. Now we'll need to see how many variables are there. In this, one variable is I and another variable is I naught. Now we can have two variable, two equation, we can solve this. After solving this, we will get the value of I naught is 0.4166 ampere, okay. If we'll put the value here, then we will get the value of RTH is equal to 2.4 ohm. Sorry, Rn is 2.4 ohm. Now what we need to calculate, see the question. They have asked in the question, find the current through 1.6 ohm, means RL is equal to 1.6 ohm, right? So we have to draw the last circuit, that is what we have calculated, current. So current is denoted by IN, and what we have calculated, Norton resistance. Norton resistance is connected in parallel with the current, and here A and B terminal are there, from where we remove the load resistance RL, that is of 1.6, right? From this we need to calculate current I. So if we will apply current divider rule, then what is the formula? I is equal to IN multiplied by RN divided by RN plus RL. Here it is RL, sorry. So IN value, what we got? IN value we got above, right? That is how much? 10 ampere, we can put it 10 ampere. Rn value is 2.4, again 2.4, RL is 1.6. so if we will calculate the value of current, I is equal to 6 ampere. That is our answer, okay. For any doubts, you can call me or contact me on my contact number. Thank you.